So you guys give me some examples of subatomic particles. This is all should be one word, so I kind of got a little bit bigger space there. So give me some particles of atoms that we know. Yes, Matthew?
Electrons.
Okay, we'll start with electrons. We can start with that. That would be fine.
Protons.
What's that?
Protons.
Yep, we're going to go one at a time. We do have protons. We'll get to that here in a second. What's the last one?
Neutrons.
Neutrons. Any others? Protons, neutrons, electrons. Any others?
Electronites.
The what?
Electronites.
No. Okay? So electrons. I like to symbolize electrons when I do a shorthand. Shorthand is always nice with notes and different things like that that you would do. Anytime to simplify things, E minus. I like to symbolize it with an E superscript minus. Okay, so when you see that, you know it's electrons. All right, so what do we know about electrons? What's that? Okay, negative charge particle. Well, very good. Most people knew that. What else?
Protons.
About electrons.
Oh.
We're still on electrons. I know protons you want to get to, but we're going to get to them. I guarantee it. Yes?
They circle around the atom.
Okay, so they're located outside on the outer portion of the atom. Okay? Okay, now you got to realize that protons and electrons really weren't discovered because they are so, the atom is so infinitely small. And now we've got these particles that make up an atom that are infinitely small compared to the size of the atom. So there's lots of experimentation that would be done in which to find the existence of these particles. We are kind of behind in this class of where we should be. So there's a couple things that I decided that we're not going to talk about because in the whole scheme of things, it's just history of how the protons and electrons were discovered. And you can read about them. It's called Rutherford's experiment, called Goldfoil experiment. We could look at the cathode ray tube and Thomson's experiment, but we're not going to, just because that's just something, added information in the whole scope of things in chemistry. Is it going to come up again? No. But this definitely is information that's very important for us to know. So we're going to skip over a little bit of that this year just because we just were a little bit behind. Right? So located in that. So another thing is that most of you don't know that the electrons make up the volume of the atom. Okay? So they make up the size of the atom. Okay? So when you look at the periodic table in the future, as you get more and more of these numbers, they get bigger. The atoms get bigger because they add these things called shells. So there's only so many electrons can fit in a shell. Then that has to expand. Okay? It's kind of like a hotel. There's only so many rooms you can put on the first floor, and once that's filled up in a certain space, then you got to go vertically up in which to add more rooms. So hotel has limited space on the ground, so it has to build on top, floors on top of one another, in which to get more and more rooms. So just like an atom would be the same way, the more and more electrons you have to occupy, then that makes those electrons get further and further and further away from the center. And that creates bigger atoms. So the more electrons you have, the bigger the atom you have. So they make up the size of the atom. Not the protons, when we get to it, not the neutrons. Okay? Now electrons are these particles. They can be the only ones that in a certain chemical process that can be lost by an atom. Protons can't be lost or transferred. Neutrons can't be transferred. Only electrons can move from one atom to another. Okay? Electrons are transferable. Some electrons aren't, depending upon where they're located in the atom. But there are some electrons that can be transferred. Okay? So we're going to say electrons can be lost and gained by an atom. And that's really important when we get into looking at chemical reactions and looking at how we put particular elements together to form a compound. Okay? Because we're going to have charged atoms. Like, for example, sodium chloride, which is table salt. Sodium is going to be a positive 1 charge because it has one less electron because it's been transferred and moved over to chlorine. And chlorine accepts that electron from sodium and it becomes negative charge. So it's very important for electrons to be lost and gained because it makes them more stable. It makes the atoms more stable when they lose electrons and gain electrons. So questions you have about electrons. Okay? Now electrons can be indicated by the atomic number. The atomic number is one of your terms. The atomic number is the number of protons in the nucleus. But if the atom's neutral, it would be the same. Electrons would be the same. Okay? So electrons and protons, they balance one another out. Right? And that's important. Oh, one more. Almost forgot this. I'm glad I didn't. They have a very small mass in relationship relative to protons. They all have small weights.
Electrons are smaller than protons.
What's that?
Electrons are smaller than protons.
They are smaller in size too, but the main thing is their weight. And that's kind of what we're looking at. So, very small mass relative to P positive, which we'll find out that's protons. It takes about 2,000 electrons to equal the weight of a proton. Okay? I give you the actual number, but you don't need that. So that just tells you they're pretty insignificant when it comes to the weight of an atom. If we look at the weight of an atom, we're definitely not going to look at electrons. If we look at a charge of an atom, you bet we're going to look at electrons when we do that. All right, so now we have good old protons. Very important to know quite a bit about protons and their characteristics. We can indicate it with a P positive. You've heard of half empty, half full before?
For sure.
What kind of person are you? Half empty or half full?
Half empty.
You're half empty.
Full.
Half full.
Half
Oh
full.
my goodness. Okay, so electrons are kind of negative, so they're always half empty, right? And protons are positive, they're always half full.
Yes.
Okay?
Oh,
So we know protons are positively charged. Okay? What else we know about protons? Yes, Logan?
They're in the middle with the neutrons.
What's that?
They're in the middle with
Okay, we'll get to neutrons in a second, but they are in the middle. Okay, they're found in the nucleus.
They have more mass than.
Yes. They're important in the mass of the atom. They're stationary. What's stationary mean?
They don't move.
They don't move. Okay? They identify the element. There's a definition, it's atomic number. They identify the element. So if I say, how many protons does barium have?
36.
How many does barium have?
56.
56. Okay? So if they say, how many protons are in uranium? 92.
92.
Okay? Every single uranium atom that you look at has 92. If it doesn't have 92, it's not uranium. Okay, if it doesn't have 92, it's not uranium. It's some other element. Okay, and so it identifies it actually gives a lot of the properties to the atom. So if you look at what gives properties to certain atoms, it's the protons that probably have a high impact on that characteristic. Right, there we have those. So we get to the last one. It's always last. It's kind of just not very exciting. Okay, it's neutron, like Jimmy Neutron, right? Okay, Jimmy Neutron. Neutrons are neutral in charge.
What? I don't know, but you're like that.
I'm doing neutron.
Oh, you don't like my turn.
Okay,
I never liked that.
it's found in the nucleus.
Carl is my favorite. I watch him every day.
I can't realize it. Good God. What? I don't know, I just...
You're definitely helping.
Not last. You know what you're
You're definitely helping.
I like the couch back at the barn run.
You know what I like? Kim Impossible. What does he do? That's what I like.
I think you guys are off topic here just a little bit. Okay, so they have no charge. They're found in the nucleus. They're important in the mass of the atom because they're about the same mass as a proton. Not exactly, but really, really close. That's as close as you can get without being the same mass. And they help identify the isotope. So when we get into isotopes here in a second, an isotope is an atom of the same element with a different weight. Now, it's not because the protons that give it its different weight. It's because of the number of neutrons that are found in the nucleus that gives its different weight. For example, hydrogen. There are 3 hydrogen atoms, okay, that you can find. One is called protium. Protium has 1 proton, no neutrons. So protium is just basically a proton, okay? Without an electron, it's just a proton, okay? Then, that's for hydrogen. Then you got deuterium. Deuterium is, if you've ever heard of heavy water is water that has more deuterium isotopes. And deuterium has 1 proton, 1 neutron in the nucleus. And then you got tritium. And tritium has 1 proton, 2 neutrons in the nucleus. So what's the difference between all of those isotopes? Protium, deuterium, and tritium. Logan?
The number of neutrons.
Right. How do the protons, do they change? No. So protons never change in any isotope. They're always going to be the same. So the neutron kind of identifies the different, Dalton said that all atoms are the same in weight. Well, hydrogen has 3 different weighted atoms. Okay. Now they're different percentages. Protium is 99.85% in a sample. So if I had a sample of 1,000 atoms of hydrogen, 999 would be 1 proton, no neutron. 1 would probably be deuterium. And tritium would be like winning the lottery. How often do you see it in the tickets that are drawn? Not very often. Okay, very, 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 very low percentage of the time. But every element has a certain number of isotopes. Some of them have a couple, and some of them have lots, depending upon what kind of isotope it is. So we're going to get into this discussion of isotopes and how they're written out. Okay? So there's 2 ways to write isotopes. There's one way that's kind of universal that you can read in the paper about, you can read in the biology textbook about, you can read, just so that people, when they read it, they're not given a symbol, but they're given the name of the element. And that's one that's most common, that if you read a news story or something in a scientific journal that's not chemistry-based, it's going to be written this way when we deal with isotopes. So it is going to be written like the following. Okay, so this is one way that it can be written. So what we're going to do is we're going to practice indicating and identifying what we call subatomic particles when we do this. And then you're going to have an activity where you're going to do the same. So I'm going to go ahead and write some things down here. We're going to go ahead and go protons. We're going to do shorthand. And then we're going to make a chart, and then we're going to do electrons, and then we're going to do neutrons, and then we're going to do mass number. Okay? So, where do I find protons for copper? Where's it at? On the periodic table, right? So, how many protons does copper have? 29. You guys see copper? Mm-hmm. See that atomic number? Atomic number tells you how many protons it has. So 29. Everybody agree with that?
Yeah.
Okay, so anytime you want to know how many protons a certain element has, look at the atomic number. They'll give you the symbol, give you the name, you got it. Now, if there's no indication that the charge is negative or positive, and we say it's neutral, then protons and neutrons, they equal one another out, and they would create what's called a neutral charge. So most substances that are free in nature by themselves will have a neutral charge. Like gold and silver, when you find them by themselves, they have a neutral charge. Because the protons and protons and electrons equal one another. So those would be the same if the charge is neutral. Okay? Now, this is really easy because what did I say makes up the mass of the atom? Protons and what? Neutrons. Protons and neutrons. So if that's the case, this is what we call the mass number. And it tells you, indicates a little bit about relative masses of atoms. So if it's 63, I can relate it to another isotope And if that other isotope has a bigger number, it has a bigger mass. And if it has a less number, it has a lower mass. So it's the mass number. So we know that protons plus neutrons is the mass number. If we add those two up, we know that's the mass number. So how do I find the number of neutrons? So protons is 29, plus neutrons equals 63. Subtract. So 63 minus 29 is what? 34. And then the mass number is 63. All right, I'm going to give you one to practice. Okay? And then I'll give you, in fact, I'll give you a couple here to look at and practice. And then we'll get into a second way that it's shown. So we're going to go here, strontium. And we'll go 88. Go ahead and fill out the rest. And then I'll give you one more. Who drives it? Isn't there a race car driver that's 88? No race fans in here? Oh, I'm surprised. In a room this size, I think there'd be some race fans with Beatrice.
Oh,
All right, let's go through. Strontium, protons? 38. Electrons? 38. Neutrons?
50.
Ooh, man, I gave you a tough one. 50 and then 88, right?
Yeah.
Okay, did you guys do the next one? We'll do that one. So, with number one, you have to access the periodic table, unless you have it memorized. Okay? You have to access the periodic table, so. All right, what element do we have?
Indium.
Indium. What's the number behind indium?
115.
115. Electrons.
49.
49. Neutrons.
66.
66. Okay? Now, chemists don't usually look at writing it this way because we don't want to look at the periodic table. We know what symbols stand for. We've got them all figured out. So chemists, what they do is they have it written a little bit different way because we don't want to have to look at the periodic table. We know the names of the symbols. I mean, we've kind of got a lot of things figured out along the way. So this would be how chemists would look at it. They'd have K, and then they would have this number up here, and then down below, they would have this number. And then if there's a charge, it would be up here. But the first one, we're not going to do a charge. So this one allows me to put charges in, and I don't have to look at the periodic table. So what element do I have? Potassium. This here is the mass number. And everybody knows what 19 is, right? It's called the atomic number, which is the number of protons. So now I don't have to look at the periodic table. So when I do my protons, electrons, neutrons, and mass number, I have everything in that, the way that's written. I don't have to look it up. So protons would be 19, electrons, 19, neutrons, 21, and then mass number 40. Got it? Now I'm going to throw a wrinkle in here. I know you'd like that. So I'm going to do one like this. I'm going to say barium. And then up above will... Oh, I did that wrong. I don't. I'm just going to put it above. I could use my eraser, but I'm not going to. Okay? So that tells you the charge. Kind of a superscript to the right. So now we need to talk about charge and how charge is created. What can only be lost by the atom? Electrons. Protons can't be lost. So you'll never change the number of protons when you have a charge. The tendency for students to do is look at this 56 and add 2 to it, thinking that it's 58 protons. So what element do you have if I have 58 protons?
You got yourselves.
Cerium. No longer barium. So the protons don't ever change. That would be 56. Okay, the mass number is 138. The neutrons are the difference between those two, like we've always done. So that would be what? That would be... would it be 82?
760. Thank you, Carson. 82.
82.
Yeah, Carson knows.
All right, here's the deal. When I do these, I'd always want to leave electrons at the end. And you don't have to. If you know this really well, you don't have to. But you look at this plus 2, and the plus 2 tells you that you have 2 particles more that are positive charged. So which ones are positively charged? Protons. So we have 2 more protons. I have 56 protons, so how many electrons do I have?
54.
54. Okay, so I'm going to give you one here. Last one is arsenic.
Oh, arsenic's my favorite one.
So go ahead and fill in arsenic. That'll be the last one. Remember, protons will never change. There's a tendency for students to always change the protons and not the electrons. You can never vary the number of protons. They are set. So protons would be 33, right?
Yeah.
And the mass number is 76. The number of neutrons is 43. I leave my electrons at the end, and I notice I have 3 more negatives, so it'd be what? 36. Okay? All right, I'm going to give you a sheet to do.